The universe is awash in a sea of stimuli, light from distant stars, sound waves rippling through the air, creating an invisible symphony, scents carried on the breeze. Our senses are constantly bombarded with information, each moment a new experience. But how do we make sense of this chaotic symphony? How do we filter and prioritize what truly matters? How do we transform raw sensory data into a meaningful understanding of the world around us? The answer lies in the fascinating interplay between sensation and perception. Imagine yourself strolling through a bustling city park where every sense is engaged. Sunlight warms your skin as the laughter of children playing rings in your ears, creating a joyful atmosphere. The aroma of freshly cut grass fills the air, mingling with the sweet scent of blooming flowers, a sensory delight. All of these sensations, the warmth, the sounds, the smells, are transformed by our brains into a cohesive perceptual experience, a seamless narrative. We don't just experience a jumble of sights, sounds, and smells. We experience the park as a unified whole, a complete picture. Join me as we journey into the captivating realm of sensation and perception, where every detail matters. We'll unravel the mysteries of how our senses gather information and how this information is processed. Explore the fascinating ways our brains organize and interpret this information, turning chaos into clarity. And delve into the intriguing phenomenon of perception, where our experiences, expectations, and emotions color our reality, shaping our understanding. So, fasten your seatbelts and get ready for a thrilling ride through the extraordinary landscape of sensation and perception, a journey that will change the way you see the world. Sensation and perception, two terms often used interchangeably, are actually distinct but interconnected processes that work together to shape our experience of the world. Sensation is the process by which our sensory receptors and nervous system receive and represent stimulus energies from our environment, acting as the initial step in our interaction with the world. It's the raw data coming in, the light hitting our eyes, the sound waves vibrating our eardrums, the pressure of a surface against our skin. These sensory inputs are the building blocks of our experiences. Perception, on the other hand, is the process of organizing and interpreting this sensory information, enabling us to recognize meaningful objects and events. It's how we make sense of the world around us. It's about making sense of the raw data, turning it into something meaningful and coherent. Without perception, the sensory data would remain just that, uninterpreted signals. Think of it this way: sensation is the delivery, while perception is the unpacking and understanding of the package. The two processes are inseparable in creating our conscious experience. To illustrate this, imagine listening to a song. The experience involves both sensation and perception working in harmony. Sensation is the sound waves hitting your eardrums, the vibrations being transmitted to your inner ear, where they are converted into neural signals. Perception is recognizing the melody, the rhythm, the lyrics. It's what makes you tap your feet and sing along. It's the interpretation that brings the music to life. Sensation provides the raw materials, the building blocks of our experience, much like bricks and mortar in construction. Perception takes these materials and constructs the walls, the windows, the roof. It builds our understanding of the world, creating a coherent structure from the raw data. Together, they form the foundation of our reality, allowing us to navigate and interpret the complexities of our environment. Our senses are remarkably sensitive, capable of detecting incredibly faint stimuli. They are our windows to the world, allowing us to experience and interact with our environment in profound ways. However, not every whisper of the wind, every flicker of light registers in our conscious awareness. Many stimuli go unnoticed, slipping past our perception without us even realizing it. There are thresholds that determine whether a stimulus will be detected, and if so, how intense it must be for us to perceive a difference. These thresholds act as gatekeepers, filtering the vast array of sensory information we encounter daily. The absolute threshold is the minimum stimulation needed to detect a particular stimulus 50% of the time. It's a fascinating concept that highlights the limits of our sensory capabilities. It's the faintest sound you can hear, the lightest touch you can feel, the dimmest light you can see. These are the moments when our senses are pushed to their limits, revealing the delicate balance of our perceptual abilities. Think of it as the boundary between sensing and not sensing. This boundary is not fixed and can shift based on various factors. But what about noticing the difference between two stimuli? This is where our perception becomes even more intriguing. That's where the difference threshold, also known as the just noticeable difference, JND, comes in. It measures our ability to detect changes in our environment. It's the minimum difference between two stimuli required for detection 50% of the time. This threshold varies depending on the type of stimulus and the context in which it is presented. Can you tell the difference between a 1-pound weight and a 2-pound weight? This is a clear example of how our senses gauge differences. What about a 10-pound weight and an 11-pound weight? The ability to notice such differences is crucial in many aspects of daily life. The difference threshold helps explain why we're more likely to notice a small change in a quiet sound than a small change in a loud sound. This principle is fundamental to understanding how we interact with our environment. These thresholds aren't fixed. They can vary depending on factors like fatigue, attention, and the importance of the stimulus. Our state of mind and physical condition play significant roles in our sensory perception. Our sensitivity to stimuli is also influenced by signal detection theory, which considers the interplay between the intensity of the stimulus, background noise, and our own experiences and expectations in perceiving the world around us. This theory provides a comprehensive framework for understanding the complexities of human perception.